Good morning. It's March 3rd, and this is your daily brief in science. Here's everything you need to know. James Harrison, known as the man with the golden arm, has passed away at the age of 88 on February 17, 2025, in a nursing home in New South Wales. His remarkable journey began at the age of 18 when he started donating plasma every 2 weeks, a commitment he maintained until he was 81. Over his lifetime, Harrison saved the lives of more than 2 million babies through his donations. Harrison's blood contained a rare antibody known as anti-D, essential for preventing a serious blood disorder in unborn babies called hemolytic disease of the fetus and newborn, or HDFN. Before the introduction of anti-D interventions in the mid-1960s, HDFN had a devastating mortality rate, claiming the lives of 1 in 2 affected babies. His contributions have been pivotal in changing this grim statistic. Since 1967, over 3 million doses of anti-D derived from Harrison's donations have been administered to 2 million mothers in Australia. His legacy continues to inspire ongoing research aimed at improving treatment for HDFN. Lifeblood CEO Stephen Cornelison highlighted Harrison's impact, noting the millions of lives positively influenced through his altruism. Harrison's unique ability to produce high levels of anti-D antibodies is believed to stem from a significant blood transfusion he received at 14 years old. The revolutionary concept of using anti-D injections to prevent HDFN emerged in the late 1950s, leading to the establishment of the first anti-D donor program. Today, the anti-D program in Australia relies on volunteer donors, with fewer than 200 participating, highlighting the urgent need for new therapies. Researchers are now working on developing a lab-created version of the anti-D antibody, referred to as James in a jar, to lessen reliance on human donors. In recognition of his contributions, Harrison was awarded the Medal of the Order of Australia in 1999, solidifying his status as a national hero. A major breakthrough in cancer treatment has emerged from the Institute of Cancer Research in London, where scientists have harnessed big data to reveal the survival strategies of various cancers. Their analysis, which involved data from over 9,300 patients, demonstrated that different backup processes are activated depending on the tumor suppressor gene affected. Dr. Syed Haider, who led the research team, explained that cancer cells can activate alternative survival pathways when a tumor suppressor gene is lost, a phenomenon referred to as buffering. The research specifically targeted cancers linked to mutations in BRCA1 and BRCA2 genes, which disrupt the body's DNA repair mechanisms. This has led to the development of targeted therapies that interrupt the cancer cell's backup survival strategies. While the findings have primarily aided patients with BRCA-mutated breast, ovarian, prostate, and pancreatic cancers, the research suggests that many other cancer types may also have similar vulnerabilities. The study identified 32 different tumor types that depend on these backup processes for survival, highlighting a wider array of potential targets for future therapies. Professor Chris Lord, a co-author of the study, remarked that these findings indicate the possibility of more precise drug design methods for specific cancers, with the hope of creating effective treatments for challenging cancer types. Funded by Cancer Research UK, Breast Cancer Now, and Walk the Walk, this research has paved the way for potentially hundreds of new drug targets, signaling the dawn of a new generation of cancer therapies. The study's results were published in the journal Nature Genetics and received support from the Cancer Genome Atlas Research Network and the NIHR Biomedical Research Center at the Royal Marsden NHS Foundation Trust. Experts stress the critical role of big data in cancer research, as it can uncover genetic alterations that cancer cells exploit, facilitating the development of synthetic lethal treatments that aim to minimize damage to healthy cells. A recent study published in the Canadian Medical Association Journal reveals a troubling trend concerning hallucinogen use. Individuals seeking emergency care after using these substances face a 2.6-fold increased risk of death within 5 years compared to the general population. The study analyzed healthcare data from over 11.4 million people in Ontario, identifying 7,954 individuals who sought acute care specifically due to hallucinogen use. Findings indicate that this group has a mortality risk nearly 10 times greater than their peers of the same age and sex in the general population. Dr. Daniel Myron from the University of Ottawa notes the absence of solid evidence regarding the safety and long-term effects of psychedelics, pointing out that clinical trials often exclude high-risk individuals. He advises that those experiencing negative reactions to hallucinogens should be closely monitored and may require intervention. Dr. Jennifer Swainson, a psychiatrist from the University of Alberta, emphasizes the necessity of medical supervision when using psychedelics, warning against their misuse outside of clinical settings. However, the study has limitations, including a lack of specific data on the types of hallucinogens used and the health backgrounds of users, which could significantly affect the outcomes. The use of hallucinogens such as ketamine, LSD, and MDMA has notably increased since the mid-2010s, with U.S. usage rates climbing from 3.8% in 2016 to 8.9% in 2021. Despite their rising popularity, there is limited data on potential adverse effects, particularly outside controlled environments. In Canada, approximately 5.9% of the population reported using psychedelics in 2023, with rates peaking at 13.9% among young adults aged 20 to 24. Alarmingly, 6.1% of those who used psychedelics died within 5 years, compared to just 0.6% of the general population, with causes of death including suicide, drug poisonings, lung disease, and cancer. The findings highlight the urgent need for ongoing research into the health risks associated with hallucinogen use as public interest and usage continue to grow. Epilepsy is a condition that impacts over 50 million individuals globally, and while anticonvulsant medications are widely prescribed, they often come with significant side effects. This situation highlights the urgent need for new and effective treatment options. Recent research is shedding light on a promising alternative: modified liposomes, which could enhance the therapeutic effectiveness of macamide-based treatments for epilepsy. The study focuses on the use of immunoliposomes to improve the delivery and efficacy of N-3-methoxybenzyl-linoleamide, or 3-MBL, a macamide known for its potential anticonvulsant properties. To optimize the delivery of 3-MBL to the brain, researchers encapsulated it in PEG-ylated liposomes that are conjugated with OX26F AB', 2 fragments. This method aims to improve the drug's ability to reach its target effectively. Characterization of these immunoliposomes showed an average size of 120.52 nanometers and a zeta potential of negative 8.57 millivolts, indicating favorable properties for drug delivery. When assessing the efficacy of encapsulated 3-MBL, results were found to be comparable to carbamazepine, a well-established FDA-approved anticonvulsant, suggesting significant therapeutic potential. In vivo tests using a pilocarpine-induced status epilepticus model demonstrated that the immunoliposomes provided superior anticonvulsant effects compared to the free form of 3-MBL at the same dosage. This research may pave the way for more effective and safer treatment options for those living with epilepsy. British scientists, referred to as the Time Lords, are at the forefront of developing a portable alternative to GPS. This innovative project aims to utilize advanced atomic clocks to counter the growing threat of GPS jamming. Recently, over 800 instances of GPS interference were reported in Lithuanian airspace, with suspicions directed towards Russia's jamming technology. The goal is to create a secure navigation system that operates independently of satellite signals, which are increasingly vulnerable to disruption. Prototypes of this new navigation system could be available within 2 to 5 years, with a vision for a national atomic clock network established by 2030. The potential economic impact of GPS jamming is substantial, with estimates indicating that the UK's financial, communication, and energy sectors could incur costs of up to £1.4 billion per day if disrupted. Current quantum clock technology is too large for everyday applications, but military research is focused on developing smaller, more cost-effective systems. Scientists face challenges similar to those encountered by John Harrison in the 18th century, as they work to isolate their technology from environmental factors that could compromise accuracy. The new optical clocks being developed promise to be 100 times more accurate than existing cesium clocks, potentially transforming timekeeping and navigation. Researchers envision a future where personal GPS systems are accessible through smartphones, featuring miniaturized optical clocks and sensors. In response to the escalating threat of GPS jamming, the UK government has initiated research programs aimed at advancing quantum technologies and new atomic clocks. A recent incident on January 17, 2025, involving a Ryanair flight from London to Vilnius, highlights the urgency of addressing GPS signal interference, as the flight was forced to divert due to jamming. This project draws inspiration from John Harrison's 18th-century marine clock invention, which significantly advanced navigation and trade. This has been your daily brief in science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.